It's the AWS Developer Podcast. In this episode, we're talking about Amazon Bedrock Agent and MCP. Good morning. Thank you for downloading the AWS Developers Podcast. We're available all Friday morning in all good podcast applications. You just search for AWS Developers Podcast. We are recording a series of episodes from the AWS Summit in Bangalore in English, in India. There might be a bit of background noise behind us. Most of it will be removed magically by AI, and AI is exactly the subject of this episode today. I'm with Tiffany. Hello, Tiffany. Thank you for joining. And we have the pleasure to welcome Vivek Raja, your AWS machine learning hero. You have a talk, you are a speaker here at the summit. You're talking about Amazon Bedrock and MCP agents. I have so many questions. Where to start? MCP agent or Bedrock?
We can start with that, yeah. Hi everyone, I'm Vivek.
Let's take all that in the correct order. Amazon Bedrock, I assume our listeners know, is a serverless managed service that allows you to access large language model. Agents are becoming more and more important. 2025, we are not talking just about Gen AI, but agentic AI. So what is an agent? What's your definition of an agent?
So if I wanted to explain what is an agent is about, it's like you define a workflow and you delegate some work to something that could do and execute something for you so that you could access some external stuff without the LLM knowing about it. So the LLM tries to delegate some of its important works, which it does not have the power to answer it by itself. So those are the powerful agents which delegates those works, executes it for them, brings back the collected answers or the results, and it gives back to LLM to make whatever the prompt was there. So these are some worker horses which is powerful workhorses, I would say.
Yeah, as a developer, I love agent because this is where I can write code and let not the model, but the system do things on top of what the model can do.
Yeah, pretty much orchestrate your code. Like so, you give it different tools and competences and it's able to think about what tools it's going to use. But what is cool is that you don't know which tools it's going to use. It decides itself.
Yeah, that's an interesting part, yeah.
But there is a difference between tools and agents, no?
Yeah, there is a subtle difference. Tools exist outside in the external world, and the agents become sort of an interface between those LLM models and those external tools so that it sort of creates a bridge between them. And your agents definitely know how to deal with them. And your LLM does not need to know about that. Yeah.
Now, tool is deterministic.
Yeah.
An agent is not. Because in an agent, it might have a part of AI. That's how I would roughly categorize it.
Yes.
I know I'm opening a debate there. Okay.
I have one slight, let's say nuance to this.
Mm-hmm.
It's if your tool is another agent.
Exactly. Yeah, because this is where it becomes blurry.
So when your tool becomes your another agent, that's where your agent talks to another agent to get the work done. And that opens up the new design pattern called multi-agent collaboration. Yeah.
And then you need an orchestrator. And we had an episode earlier about multi-agent orchestrator. There is something that changed the world of agent like 6 months ago, and everybody is talking about that in this area. It's MCP. So yes, can you explain what is an MCP? What is MCP first, and then what is an MCP server and client? And
yeah, we go at it. So MCP stands for Model Context Protocol. It is a open source standardized protocol which is put out by Anthropic. And if I wanted to explain for anyone who's joining in new, if I wanted to explain that what is an MCP, you could imagine that as an USB for LLM or for the external data. So
universal bus, I can plug anything on it.
Yeah, exactly. So how your USB sort of establish a standard to plug and play with any peripheral that is out there. So now we have evolved so much. Now the LLM could plug and play with different data sources. And that protocol which helps you to plug and play is your MCP.
Is it the LLM or is it the agent talking to the LLM?
It could. Yeah, it's an agent which could talk to the external tools and the word. Yeah.
So it's a standard protocol that allows to call a tool, whoever is writing the tool and wherever is running the tool. Actually.
Exactly. And so once you start establishing, so how REST APIs where standardize the entire way how we communicate with web services and everything. That changed the way how we deal with it. Now this MCP protocol is establishing that standard, how you interact with other external data sources for your LLM.
I have white hair. It's something that you cannot see if you're listening to us. But I'm in this industry since more than 30 years, and I saw different ways to reuse existing code. We call that core bar, RPC calls. We call that EGB, COM, DCOM. What else? REST web services. Yeah. So how MCP is different? Why?
So actually, MCP actually allows you to reuse for different LLMs that you wanted to access for. So the reusability and the standardization is the two key aspects for your MCP protocol, because now you don't have to rewire or hard code something for your agents to talk to a specific data source. Now this could be a standard. You could reuse it to any agents, any host LLM that you want that wants to leverage it, and you just have to keep those things, MCP servers, clients, and the config stored, and that could keep on interacting with anything that you wanted to build it. So how API is sort of the interface for everything, and you just don't care about what changes on the other side. You just need to care about what parameters you are passing to an API. Similarly, your agent needs to just care about what parameters you're passing to MCP, and you could reuse to anything that you wanted to use it. Yeah,
I think that's the groundbreaking idea of MCP. You said it very well, is that before we had agents, so LLMs that could do actions. Now we are decoupling the LLM with the tools. And that's what is making it really interesting. It's that because you can have an LLM, a client, going into any servers, tapping onto any tools. You don't even have to create the tool yourself. You could tap on someone else's tool because they're serving it and they're opening, like as you said, like a BI call, like an API call. This is why this is so interesting.
Exactly.
If you're a regular listener of this podcast, you know that I like concrete and reality. Can you give a couple of examples of an MCP tool that can be useful for developers?
Yeah. So one interesting use case that I came across, which I would like to do it here. So let me try to break down how I was implementing it earlier versus how we are implementing now with MCP.
Yeah, that's a good idea.
So that would give us what's the boost that we have, the advantage what we have here, right? So let's assume that you are creating a ticket booking AI agent. So that is responsible.
So like a flight ticket?
Yeah, like a flight ticket. Okay. So let's imagine the enterprise is sort of creating a travel agent, travel AI agent, ticket booking AI agent, and that takes care of ticket booking for your entire employees of your organization. So the ultimate purpose of that is to find out where the tickets needs to be booked, what platform is it, go and interact with the platforms over the API, query the employee details when they input it so that it could fill those necessary details there and do it. So before MCP, when agents were there and when we were doing it, so we primarily use two things here. So one is function calling to call functions, which is your platform or whatever it is we are doing to query those ticketing platforms or send or receive data from it. The other one is your private knowledge base, because your organization has employee directory and you need to fetch their details so that you could book a ticket for them, right? So you have your agent interacts with your knowledge base and your agents interacts with the ticket booking platform. Now comes the interesting part.
Let's go.
Now, let's assume that the way how you book a ticket with the platform changes. So someone changed the way how you interact with them. They might be enforced a new security protocol, or the parameters that you need to ping them changes. So the whole system is now broken. No one can book tickets. So what they have to do is go and rework on the function so that you could change it, redeploy it. So that's how it works without an MCP. Now MCP comes into the picture. The ticket booking platform sort of releases an MCP server, which sort of a config. You can imagine an MCP server is nothing but a config file. It allows you like what you can do with it, what's the parameters you could pass to that, what are the security constraints that it needs to enforce. And then you write a small MCP client where you ask like, okay, now book tickets for Vivek from Bangalore to Seattle for AWS Hero Summit. I don't have to really do anything about it. It goes and picks my name and my details talks to the MCP client and gives that. MCP client goes and talks to your MCP server that ticketing platform gave, and it does the job for you. So now whoever changes anything about the ticketing platform doesn't matter. Whoever changes anything for the knowledge base doesn't matter, because we have abstracted both of them.
Because it's on the server side to make sure that the lump, like the function, works. Like it responds to your LLM properly.
Yeah, maybe if I wanted to put one more extra step to it, like I say that Vivek only wants to go when the weather is good. There should not be any turbulences. Now, do you think that the conventional way of function calling would work? Because I don't have access to weather data. Now I need to write a separate thing for it. Now, if there is an MCP server client for weather data access as part of this server configs, it could still go and ping weather APIs, get the information, get necessary decisions made, and it brings out me the right flight and book for me. So that simplifies everything.
Yeah, in the past, if I want to orchestrate REST API as a developer, I have to be sure that I collect all the data that I need to invoke my next function. Here, the model is doing that for us. It figures out what are the parameters I need, where can I find this information, maybe calling another MCP server to get that info, collect everything. That's the kind almost magical part of it.
Exactly, yeah.
As developer, I love to play with tools because I feel I'm back in control when I'm using an LLM and a Gen AI system. MCP server fits into that category, but you know that we all know that Gen AI, and even machine learning is nothing without data. So there is still like a duality. On one side, there is the data owner, the guys and the folks within the company that manage the data, and the other side's the developer. Are we going to bring these two together, doing like DevOps did for deployment and development a couple of years ago?
Yeah. So if you take the data owner's personality, they do not like when someone accesses their data. So they want the data to be secure. So any enterprises wants that.
So that's an antinomic, like, yeah, it's conflicting. On one side, compliance, where nobody to access the data, but if we want to do something that has some business value, we need to access the data.
Exactly. So now this MCP server client architecture actually standardizes the way how we access internal tools and data. So your data owners stay in control of whatever data that you have, and they release this standardized protocol for accessing the data. And with this, you could even enforce what's the authentication method, what sort of which data you need to actually bring out and everything. That actually allows you two things. One, it actually breaks down the data silos. So before MCP, you need to know what data is lying out there to exactly go and query for it. It could be a database, it could be a files lying around in S3 bucket or whatsoever, or it could be an external tools or whatever it is. Now you don't really care about that. You just need to, so that all those data silos are broken down, but without actually compromising the governance of it. So the data owners still govern those data, and the developers have a standardized way of accessing it. So it's like a one-time setup. The developers access it, data owners accesses it and maintains it. Even if there is any change in the structure of where the data is residing, the developers do not need to know about it or worry about that.
But what's the mechanism under the cover to propagate the user identity or its permission to an MCP server?
Yeah, you can use a lot of authentication. So you can even use an OAuth 2 as an authentication towards it. So which means every single interactions that you do could be actually managed. And there is actually a config called auto approved. So if you enable it, your all your interactions could be passed through. Or if you do not want that auto approved to be, so you keep a guardrail over there to ensure that no harmful interactions are being taken care of.
But basically, at the wire level, it's a JWT token that the agent sends to the MCP server, and from there, it's up to the code to do something with that JWT token.
Exactly, how any client and server interacts with them. So you could still establish an authenticated way of interacting with your server. So it could be an OAuth authentication or whatever it is. So you could still establish all those security measures over there.
Where do you deploy your agent? Deploying agent, at the end, it's code. It needs to run on some kind of compute. So what do you observe with your customers?
So the thing is, you don't really need to do everything on your own, right? So when there are managed services doing it for you, I think the best way is that leverage it, and it's always much secure and the cost is pretty less.
So you're talking about Bedrock there?
Yeah, exactly. I'm coming over to that. Okay. So Amazon Bedrock helps you to orchestrate everything. So from LLMs to knowledge bases, where you can implement RAD for it for your custom data, and also it has all the agentic workflows under AI agents. So Bedrock supports AI agent. Now you could orchestrate like whatever AI agents that you wanted to create, you can create it, manage it, and now you could also manage your clients, MCP clients and servers. So you could now instruct your Bedrock AI agents on how you need to access your external tools and data.
Wait. Because as far as I know, as of today, we are recording this podcast beginning of May, the 8th, to be precise. Amazon Bedrock agent does not support MCP client or server. So when you say you can call, it means as a developer, I need to write an Amazon Bedrock agent that acts as an MCP client to call an MCP server.
Yes, we have to write an MCP client for it. Okay. Given that there is already an MCP server that you have written for any AWS service or external tool that is already available. So it's your responsibility to write the MCP client on how you interact with the server there. But the workflow for the AI agent is already established because it's already there.
Okay, so the workflow is coming from Amazon Bedrock.
Yeah, the AI workflow is in Bedrock already. Yes. Yeah.
And it's your responsibility to write the config for your MCP client. And given that there is an MCP server already existing for the service or APIs or external tools or knowledge bases already existing, now this MCP client interacts with those servers to pull the data from. So one interesting use case that I came across from AWS blogs is that there is how you could interact from your Claude Perplexity model. If you ask like, what is my cost spending in AWS looks like? So your Perplexity model does not have it. Your Claude model does not have access to your AWS services, right? So now how do you bring? So it sort of makes sense if some LLM model residing in Amazon platform gets it for you. Like still that's not possible. But imagine something very external model tries to access a data from Amazon and it gives you the result. So here, let's imagine there is our budget spending and cost tracker has an MCP server. You could write an Bedrock agent which has an MCP client which talks to the MCP server of those cost, AWS CloudWatch cost, and it brings the data. Now a LLM can just trigger the agent to get their answers from. So that's how this whole workflow happens in Amazon Bedrock.
I told you we are recording live from the AWS Summit in Bangalore. In India, you might hear a bit of background noise, microphone, Larsen, and everything. But that's the chance to talk with speakers here at the summit. And Vivek, you're one of these speakers.
So all the connections that you're talking about, it's SSE, right? We've also seen recently HTTP streamable.
Yes.
The way you've built your connections is through SSE?
Yes, exactly. Through SSE, yes.
Okay.
So when you said that many AWS services are exposed through MCP server, it's not yet the case in the service directly. Maybe it will be by the time you're listening to this podcast. We don't know. Things are changing so quickly in this area. But right now, AWS has developed a bunch of open source MCP server.
Yeah.
Have you had the time to explore some of them? What can we find there?
So one thing which I personally worked on is the CloudWatch, to where we could get the cost tracker. So that's one of the deep dive technical sessions would I be doing a hands-on pretty soon on that front. That's all also what I came across one in the AWS blog when they were talking about how we could harness AI agents and MCP server with that. So that's something I'm very familiar of, as of now.
So the use case there is I install these agents somewhere on my network. This agent needs to have access to my account like CloudWatch or the billing. If it is a Lambda function, it's probably through IAM roles or even for EC2 or containers. And then I just put the configuration in an AI agent, MCP enabled, and I can start to chat with my AWS bill. That's the idea.
Exactly.
What is my cost for EC2 last month in US East 1?
So not sure about that, but if I wanted to break you down on how that implementation sort of goes out, like what do you exactly do in like those MCP client and the server architecture? So let's not worry about the host, who is a LLM is. It could be anything. It could be a Claude model. It could be your Amazon Titan or Nova, whatever it is. But if you start writing the client that you wanted to write for this, so you need to first establish a config file for that for your MCP client. So let's imagine I'm creating for that. First, you need to pass all the parameters that your server requires. So you need to be aware of how that MCP format looks like, first of all. So next is you try to create all those. You need an IAM access. You need access to the servers. So make sure that your IAM has an access to that servers and so on. And then you also give all those, what is that? If you want to do log it, you can give the Bedrock log name and everything. And then you can pass all the environmental files like environment keys, like what is your AWS access ID, your secret, your region, and your Bedrock log group name and so on. So then you have to, so we are interacting with two things. One is it can also go and interact with another LLM if it wants to as well. So you need to, if you are doing that, you need to give permissions for it, access key for that as well. So these are your clients which do that. And then when you actually come about the server parameters, so it takes all those config and then it passes down to that server config file. So it creates it. So you need to be aware of who's releasing the server and the parameters that you need to pass for it. So once that is available, it's easy to do that. So similarly, when you go and create an API for your application to access some backend data or something, they give you a Swagger file about all the API specification document, like what it actually needs and what it returns back. So you get to see that MCP server's parameters that it needs to have it. Then actually you can now, when you go back to Bedrock, you can create a Bedrock agent. Now here is where you can actually invoke it. When you create so under the Bedrock, you can create an action group. And under the action group is where you call this MCP client to be invoked. So your LLM interacts with the agent invokes the client talks to the MCP server, MCP server goes and collects your data for you, and then gives it back. The agent makes intelligent decisions. It can make much more calls if it needs, if it have accesses, and then it gives back to the LLM, and the LLM decides what to talk back to the user, and that's how it works.
At the moment, if you want to deploy such a project into production, is there a way to does it work with CloudFormation or infrastructure as code? Yeah,
absolutely. Because at the end of the day, it's Bedrock gives you the agent workflow. You can use an SDK or CloudFormation. I prefer SDKs more like as a developer hands-on. So I use an SDK, write all this in Python. And then you could always write all those MCP clients and everything as a Python file, and you just need to invoke it. That's it. So that's where you try to interact with the clients, and then you do that. So it could be Dockerized, and or it could be in CloudFormation, and you could still establish the whole workflow without you having to manually do it every single time.
Yeah, when I was listening to you talking about the Bedrock agent that act as an MCP client, I was thinking there is a lot of reusable code. There is a lot of undifferentiated heavy lifting, like Werner Vogel's like to say. So is there anything that we can reuse? Maybe there is like a skeleton, a framework, open source somewhere that we can use as a starting point?
Right now, people have started populating, people started releasing the MCP servers for the services or the data houses or tools that they had. So that is one place where you could get access to. But in an organization or in an enterprise, people do organize this MCP clients, and maybe if they write services for their own internal tools, there might be services. So they version it out and maintain the complete book of what all clients they have and so on. So if a developer wants to access a particular data, all they have to go and check whether the client is already available. They can take that code, reuse it, or ping that client. And there is already, if they wanted to access some particular code, there's already a log or a group of MCP servers already logged by the organization. And it's right now, from the organization level, it's maintained. Like I've seen on enterprises using around 40 to 50 plus MCP servers and clients already made and stored for the organization to use. So now the reusability is there and the standardization is there, and it's already available as a gift. So you can just pick out and use whatever you want.
From your experience, is it better, you think, to have few LLMs have access to a lot of tools, or is it better to have access to few tools but more agents collaborating with each other?
I would say that you could have a lot of agents. Depending on, it's about how you wanted to establish the pattern here, your architecture pattern here. So the fundamental thumb rule when you write a agent is that it is focusing on one action item or one particular context of task. So if you feel that the context of the agent differs from another one, then you have to create a new AI agent. So you could create as much as AI agent. Your LLM is replaceable. It's a model agnostic one. So you don't really need to care about whether how many LLMs you have or not. But agent wise, yes, you have to be a little bit careful whether you want to establish more agents or less agents depending on your use case. And then I would say that every single data source or that could be accessed should start having its own MCP server configs. And if you prefer to accessing it more, I would prefer you to start writing MCP client for that, so you could keep on reusing it. So answer to your question would be go for more agents depending on the context, and always have an MCP standardization protocol. That is a protocol here, right? So have an MCP for your data tools so that could be easily accessed, and no one really cares how the structure is or how what sort of maintenance goes beyond that.
I've noticed that too with it, through my experience, but I was curious to know yours because there's no really standard at the moment of this. But I noticed that if you give too many tools to the same agent, then sometimes it gets confused to which one is to use, and it's better to have several agents specialized with fewer tools. But yeah,
exactly. So it depends upon for example, you can pass down one results of an agent to another agent to make much more intelligent decisions. So that's how multi-agent collaborations happens. So it's not really a bad pattern, but you could still manage it based on how your use cases are. So as I said, if we pick back the same example that we picked up earlier, I wanted to book a ticket for Vivek, but I also just wanted to make sure that there's no turbulences that's happening on that particular week. So I could create a smart travel assistant AI agent that could still have access to both the ticketing platform as well as the weather API. So it still falls under the same context. But if there is something that is going way beyond the context, that's where you have to go and create another AI agent. And maybe if there is a dependency that's lying around, make sure you have the collaboration happening there.
Does it depend also on the model that you're using? Because at the end, it's the model doing the orchestration and deciding which tool to call with which parameter. Models are roughly a commodity these days. I'm sorry if you're building models, you might disagree with me, but from a developer point of view, I can use one or the other. But there must be difference in their capacity of reasoning and calling the right tool with the right argument.
Yeah, exactly. So at the end of the day, as a developer, you define that you are working on a use case. Your enterprise has a bigger problem to solve. So you can decide which model gives you the right reasoning and which model gives you the right. For example, if it's more code generated, you should go for a model which is more good at the code generation. Yeah. And if you feel that it's more on the reasoning part, go for agents which are more into reasoning. So that's how you can pick and choose which models that you want to play with, and that orchestrates much more better for you.
Yeah, and definitely if you have an agent that has access to a lot of tools, and sometimes they have to use a combination of those different tools. So sometimes you think that the agent will just use one tool, but you actually want them to use several tools in sequence exactly. But it needs some sort of reason to do that. And if you want an agent that is able to use those tools and sequence them in a timely manner, then yes, having an LLM that has a better reflection is best.
That's true. And also your prompt plays a vital role when you're interacting with the model here. So if your prompt is bad, then it might not do the right orchestration there to pick out the right agent and whatever the clients, MCP clients that it has to invoke.
Even more though, the system prompt for those agents are they must be really nicely designed to understand what tools it has, like how it has to think of those tools. Maybe it has to use them sequentially, and the system prompt needs to be very well designed. But that's cool because it's on your side.
Yeah,
it's not on the user side.
Yeah, exactly. Yes.
So what are the main challenges as a developer I have to think about when creating such a system, when creating my Bedrock agents that are MCP clients, or when writing MCP server? Probably it's two questions. One is for the agent and the MCP client, and the other for the servers.
Now everything is getting standardized. Earlier it was a lot of fragmented items over there, and right now we are standardizing everything. So you don't have to build all the custom flows from scratch. So that's a plus point for the developer. And again, this is a plug and play, as we already spoke about. So you don't really need to care about what changes in your which data source that you want to interact with. So you go plug, you get the data or the results, plug back. You don't really need to care about it. So, and from a developer's perspective, I would see that me interacting, like for example, if it is a function call or as a function call, as an agent doing a function call and so, I need to be aware of what that Lambda function or demands for me and so on. But here is that everything is standardized. My learning curve of using it's much more easy. So as a developer, I would really appreciate that this is coming over in a way. So because at the end of the day, it's nothing but a bunch of config files lying around, and you just need to pick out the right one for you.
It's only putting config files at the right place.
Yeah. Maybe we could, if we dump this down, maybe it comes down all to that. Yeah.
No, trust me, it's a bit more it's a bit more complicated than that. And as a developer, we still need to write code. I think MCP is a fantastic world. As I said earlier, it gives developer a bit of control to what's happening inside a GenAI system. It's very difficult to have a perspective on the future because this field is changing so quickly. MCP did not exist 6 months ago.
Yeah.
But in your opinion, where are we going in the next 6 months, 1 year, or maybe beyond?
Oh, great. So for that question, so Arvind Srinivas, the CEO of Perplexity, so when he actually was asked like how do you plan for his company with this quickly changing, evolving AI, he said like it doesn't plan for more than a quarter. So that's how fast this AI is evolving, right? So in that context, I would still stick to him, align with them. So things are changing quite fast. So what I would say is this is my opinion, and I strongly suggest it for everyone, recommend it, is that there are a lot of things that always comes up, and it might be lucrative for your implementation or for your company or your enterprise. So you need to start evaluating whether it really fits your problem statement. Does it really solve your problem statement the effective way? So you could still use an LLM to do a classification problem, machine learning problem, or go for a very simple classifier model, which is already available as an AI service. You save a ton of money as well as you are contributing back to the climate. Yeah, to the planet.
Exactly.
So again, coming back to the question, so AI is evolving so fast. Keep up with the trend, but you still have the power to control what it comes down to your problem solving skills and what you really need to solve that with. So my thing is that it's making our lives much easier. So you have the power to decide how it want to impact you on which level.
Yeah, and if you have a challenge to solve or a business problem to solve, MCP is not always the answer. Yeah. It should be in very specific use case. Let's not be over enthusiastic with all the possibilities that are offered there. And good old algorithms sometimes bugs, experiments as well. And as you said, it's better for the planet as well because all these technologies are consuming a lot of electricity. Vivek Raja, AWS machine learning hero, thank you for being in the AWS Developers Podcast today. Thank you, Tiffany, for your questions, enlightenment, explanations as well. Thank you for having listened to this episode until the end. See you next week in another episode of the AWS Developer Podcast. But now, go build.